Hello class, welcome to this video on the chapter 6, random variables, probability distributions practice. So the test is supposed to be on 6.3, which is on binomial and geometric distributions. This has a little bit of normal distributions as well. So it has a few normal distribution questions, which is fine because we do tie in normal approximations to binomial anyways. And it has a little bit of 6.1 in as well in the first question. Let's look at the first question here. The spinner shown to the right is split into two sections, with the smaller of the two containing 20% of the area. A simulation was conducted in which a trial consisted of spinning the spinner 5 times, recording the number of times it landed in the smaller section. Many trials of the simulation were conducted, and the results are shown in the histogram below. So this is a binomial distribution. If you're looking at success and failure for, the spinner landing on the blue region, right? Success for blue, not success for not blue. And it has independent. Each spin is independent. The number of trials is 5, right? And so on and so forth. So this is just showing you the shape of the binomial distribution. So based on the results of the simulation, which of the following is closest to the probability that at least 3 spins land in the smaller section? So here they already give you the graph of the probability distribution. So there's no sense in trying to calculate the probabilities. You just use the graph that they give you. So here, this is about 0.05 and you want 3 or more at least, right? And then this looks like about half, so I would just estimate it as half. Half of 5 is 2.5%. So if I add those 3 together, that's 5 plus 5. If I add these 2 together, I get 10%, right? So 0.05 plus 0.025 plus 0.025, that's about 10%, 0.10. And so the closest answer to that is 9%, so the answer is B. Number 2, according to a 2021 survey, 74% of employees working for the local university claimed they would rather work in person than remote from home. All right, random sample of 20 university employees will be selected. What is the probability 8 of the selected employees claim they would rather work in person? So in this case, the probability of success is 0.74 as far as they would rather work in person. And then we have 20 trials, 20 university employees. So we have probability of success is the same. We have the number of trials, right? So we have, we just did these 2, right? So check for those 2. Each employee is independent from the next in their preferences. And then binomial or binary success or failure, right? They would rather work in person versus not in person. All right, so in this case is binomial. So the probability that we have x is equal to 8. You just have to know how to plug into the formula. The formula is n choose x, p to the x, and then 1 minus p to the n minus x power. So, we know that it says 8 of the employees, so x is 8, right? So we got 8 here, and n is 20, so we got 20 there. And then p is, of course, 0.74. So he's got to plug it in there. So the answer is B. All right, so number 3. In the United States, 75% of adults live in the same state that they were raised in as children. A random sample of 10 adults in the United States will be selected. Which of the following is closest to the probability that fewer than 8 of the selected adults live in the same state as they did as children? So this is a binomial distribution. We are looking, 75, it says select adults, so 75% live in the same state, so P is 0.75. We have n is equal to 10 adults, and then it says we want that to be less than or equal to 8, right? Or fewer than 8 means less than 8. Okay, so then we're using a binomial distribution, binom CDF, and remember that since we're doing the probability that x is less than 8, the binomial CDF function only applies to less than or equal to. So it's got to be less than or equal to 7 in this case. So it's binom CDF of n equals 10, p equals 0.75, x equals 7. Okay, so we can calculate that and get that solution. So if you did that, the answer is C. All right, so number 4, a factory that produces cream-filled donuts has determined that 6% of the donuts made on the production line are overfilled. Suppose 300 donuts will be sampled from the production line and that donuts are filled independently of one another. Which value is closest to the standard deviation for the distribution representing the number of overfilled donuts from the 300 randomly selected? Okay, so standard deviation representing the number of overfilled donuts. Okay, so this is a binomial distribution. We can see we're saying the distribution representing the number of overfilled donuts. So it's whether they're overfilled or not. And then we're looking for a sample of 300. So sample number of trials is fixed. Probability of success is 6%, right, in this case. So this is binomial. And so the standard deviation is the square root of np times 1 minus p. We have the square root of 300 times 0.06 times 1 minus 0.06. All right, and we'll calculate that. All right, and if you calculate that, the answer is 4.11, so it's going to be B. Number 5, in the state of South Carolina, it is determined 18% of the population have a high school diploma as their highest level of education received. 27% of the population have a 4-year college degree. Random sample of 500 people will be selected. All right, so we got that. That's important. 18% of the population have a high school diploma. 27% of the population have a 4-year. Okay, so 18% have high school, 27% have that. Let random variable H represent the number of citizens with the highest level of education at a high school diploma from the sample, and random variable C represents the number of citizens with the highest level of education at a 4-year college degree from the sample. By how much will the mean of C exceed the mean of H? Okay, so then if we assume that these are both binomial distributions, which means success or not, whether they have the diploma or not, whether they have the education or not, each person is independent, number of trials is fixed, 500 people, same probability of success. All right, so if we assume that, that's in binomial. Well then, in that case, okay, so then mu of high school is, we got 500. Remember the formula is n times p for the binomial distribution, right? The mean. So we got 500 people times probability of success for them is 0.18. And then we want to compare that with mu of college. Okay, so mu of college, we'll do it over here on the left side. So 500 500 times for them is 0.27%. Okay, so then we have 500 times 0.27, and we're going to compare that with 500 times 0.18. Let's do that real quick. So this one is 135. And this one is 90. Okay, so this is by how much will the mean exceed? So it's 135 minus 90 is 45 people. All right, so the answer is B. All right, number 6. According to dental records, it was determined that 5513 out of 82,664 patients seen at a large nationwide dental office floss their teeth daily. Consider a sample of 600 patients from the dental office. Which of the following is the closest to the expected value of the number of patients that floss daily in the sample? So we want the expected value. So that's mu x. So whether they floss or not, success or failure, we have a certain probability, right, which is determined from data. So we can use that as our probability of success. We can assume that that's the same probability of success. And then each person is independent, and then number of trials is fixed if we're looking at 600 patients. So we could just calculate 600. We can use a binomial. 600 times the probability of success. So 5513 out of 82,664. All right, and then we'll calculate that. Let's see. All right, so you get about 40 patients. All right, so the answer is C. All right, number 7. A hotel in Miami, Florida has determined 90% of their hotel guests will check out their hotel's room on time. It is appropriate to assume independence between hotel guest checkout time. Suppose 30 hotel guests will be randomly selected, letting the random variable x represent the number of hotel guests from the sample that will have on-time checkout. Which statement is the best interpretation of random variable x? Okay. All right, so first, does it satisfy bins, right? B-I-N-S. Let's see if that's true. So yes, binary, whether they on-time checkout or not, right? And each person is independent. The number of trials is 30, randomly selected, so it's fixed. Success, probability of success remains the same. All right, so it's a binomial variable, so it can't be D or E. So either A through C. So let's calculate it. Mu x is n times p. So 0.90 is the probability of success times 30. Let me do 30 people times 0.90. I want to keep it in the same order. 30 times 0.90, which is 27 people. Okay, so it's not C because it says 30. It's A or B. So let's calculate the standard deviation. Oh yeah, it looks like the standard deviation is going to be the same for both of those. But let me just calculate anyways, just to practice. So we got 30 times 0.90 times 0.10. Remember, it's n times p times 1 minus p. And so if you do that, you get a square root of 2.7. Okay, so is it hotels or guests? Well, here it says, let's see, it says, let the random variable x represent the number of hotel guests. So we're looking at guests, okay? So the answer has to be A. All right, so number 8, Fruity Puff cereal contains 3 different fruit flavors, all mixed together in the same cereal box. The production for the cereal is set to allow 40% of the cereal puffs to be flavored blueberry. Okay, so we got 0.40. Factory completes quality control checks. They take a random sample of n fruit puffs, so we don't actually know what n is, it's just n. Let the random variable b represent the number of blueberry flavored fruit puffs in each sample, the variance. So they give you the variance here. So they give you sigma squared is 12. Which of the following is the best interpretation of the random variable b? Well, okay, so is it binomial? Well, first off, so does it satisfy bins? The answer is yes. Blueberry or not, right? Be binary. Each one is independent from another. The number of fruit puffs is n. We don't know what it is, but we do know that it says that there's a random sample of n, so that number is fixed. And then we have S, probability of success is 40%, stays the same. All right, so let's figure out what n is, though, because we don't actually know how many independent trials we have. So that eliminates D and E, so it has to be A through C. Now, we know that to calculate the standard deviation, we had to take as the square root of np times 1 minus p, right? And so that means that the variance is equal to np times 1 minus p. All right, and so what we want to do is we know that the variance is 12, right? So we just plug in 12 there. So we get 12 equals n p times 1 minus p. Well, p is 0.40. Okay, so we got 0.40 times 0.60. So we got 0.4 times 0.6, which should be 0.24. So we have 0.24 n. Okay, then divide by both sides by 0.24 to solve for n. All right, so let's go ahead and do that real quick. It should be a large number, so I'd imagine. Let me see, 12 divided by, I imagine it be in the hundreds, or maybe, or no, it's going to be not hundreds. It's going to be bigger, but not that big. So it looks like I got 50. Yeah, that makes sense because 12 out of 24. Okay, so as we got 50 independent trials. So the answer is B. Okay, all right, so number 9, approximately 27% of the US population has blue eyes. Okay, so 27%, so probably 0.27 for that. Let the random variable y represent the number of US citizens with blue eyes in a random sample of 50 citizens. Okay, so n equals 50. and they say y is blue eyes. Okay, so assume the random variable y follows a binomial distribution. What is described by the value of that? Okay, so this is the number of trials, number of people in the sample, U.S. citizens, and then we want 10 with blue eyes. So we're finding the probability that there's 10 with blue eyes, right? And then those are the percentages. Okay, so the probability that exactly 10 citizens in the sample will have blue eyes. So the answer is D. All right, number 10. A nationwide standardized test creates 5 different versions of the same test by reordering the questions and answer choices to help reduce cheating. The likelihood of receiving any of the 5 versions is equal, and it is fair to assume independence of the versions received. Which of the following is the probability that the first version A of the test to be administered is assigned to the 7th student? All right, so there's a keyword there, that the first version is assigned to the 7th student. So this is actually, we actually don't know the number of trials in general. We're just saying that specifically in this instance, that the 7th student received the first version. So this is fibs, okay? When you see the first, or when you see something that repeats until you get a success, that's fibs, which is geometric. So first, repeat until you get the first, version A in this case. Binary, version A or not version A. Independent, each test is independent. Probability of success, yes, it's one out of 5 for you to get version A. Okay, so we can calculate this. So we get P is 1/5, and we want the probability that is assigned to the 7th student. So when we get to the 7th student, we get 7 people before we get the first success. All right, so remember that the binomial, or not the binomial, the geometric formula is 1 minus p to the x minus 1 times p. So we can calculate that. All right, so we got 1 minus 1/5 to the 7 minus 1, or 6 power, times 1/5. We can also use geomet or PDF, not CDF. PDF is for a specific value of p equals 1/5, x equals 7. Okay, and then you'll get your answer there. Okay, and then the answer is B. All right, number 11. If 15% of a large high school's population is currently enrolled in a pre-calculus class, all right, 15%. What is the probability that the administrator who's randomly selecting students will find the first student to say that they're enrolled? Okay, the first student, that's fibs, right? Each person is independent. They're enrolled or in pre-calculus or not. First person to be selected. Probability of success is the same, 0.15. And it says within the first 3 students they polled. So what's the probability that they will find the first student to say they're enrolled within the first 3 students they poll? So within means less than or equal to. So that means it could be the first student or the second student or the third student within the first. Okay, so we want the probability that x is less than or equal to 3. So since it's less than or equal to, we can use the CDF function. So geomet CDF p equals 0.15 comma x equals 3. Okay, and so the answer is E if you did that. Okay, all right, so let's look at number 12. Approximately 6% of the population is planning on attending the spring event. Okay, city council will randomly select students until they find somebody, so that's clearly, looks like geometric. What is the expected number of residents they will be keen to ask in order to find someone who is planning to attend? Okay, so the expected number, so that's an expected value. So since it's a geometric, it's 1 over p. So it's 1 over 0.06, because it says p is attending the spring event, and then that's what they want. They want somebody who's planning to attend it. So 1 over 0.06, which is equal to 16.67. And so the closest answer to that is 17. All right, and remember, this is when you're talking about an average, it's okay to have a decimal for average, right? remember 16.67 is an average. And so is standard deviation. That's a type of average as well. All right, so number 13. The random variable L has a geometric distribution with mean 20. Which of the following is closest to the standard deviation? All right, so they said the mean is 20 and it's geometric. So we know that the mu x is 1 over p, and then they said that's 20, right? So we're going to solve for p here. So p is 1 over 20. And that's my p, which is 0.05. All right, and then we can find the standard deviation. So then the standard deviation is the square root of 1 minus p divided by p. Okay, we can calculate that. All right, and then the answer for that is C. All right, 14. The planning committee at the Performing Arts Center expects 82% of ticket holders to make a purchase from the concession stand. If the upcoming performance has sold 940 tickets, and then it says 82%, so 0.82. And then, okay, use a normal model to determine the probability that at least 780 will make a purchase from the concession stand. Okay, so this is a binomial, but we're using a normal to determine that probability, right? So we have 940 tickets, so that's going to be my n. N is 940, the number of trials. And at least 780, that's going to be it's saying greater than or equal to 780, right? So x is greater than or equal to 780. So that's the probability that we want to find, right? Okay, so we're gonna remember we're using a binomial here, but we're using a normal model for it to approximate it, and we can do that because it satisfies the success failure condition, or it would, that's normally what it would entail. You have to satisfy that in order to use the normal. So we're going to use the NP for the the mean for the binomial for the normal model. And we're going to use this right here. So we get n times p, that's 940 times 0.82. And then we'll figure out what that is for the standard deviation as well. I'll just write it out here. Okay, so I get 770.8 for this. And I get 11.78 for the standard deviation. Okay, so then we want the, in this case, we want the probability that x is less than or greater than or equal to 780, right? So the probability x is greater than or equal to 780. So we can use the normal CDF. So we got normal CDF, and we got our lower. We want it to be greater than. So that means the lower is equal to 780. The upper is like 10 to the 9th power or 1,000, whatever, a big number. And the mean is, so the mean is 770.8, and the standard deviation is 11.78. So we'll do that and see the answer that we get. All right, and if you calculate that, you get about 0.2174. All right, which is B. All right, okay, so number 15, Paraville University always administers a satisfaction survey to students upon graduation, asking about how pleased they are with the experience they received at the university. For many years, the satisfaction rating has been quite high. 90% claimed they were very satisfied. Past graduating class had 4,100 students, of which 3,650 claimed they were satisfied. Should Paraville be concerned that satisfaction ratings may have changed significantly this past year? Okay, so let's see. This is a binomial, right? You could use a binomial here. Satisfied or not satisfied. Each person is independent. Number of trials. In this case, we have 4,100 students. So number of trials is the same. And then the probability is the same, 90%, right? So n equals 4,100. Let's calculate the expected value. So what would we expect it to be it would be 4100 times 0.90, right? So in other words, 90% of 4100, which should be 4100 minus 410. So let me do that. So it's 3690. And then, okay, so we have 3690 for that. And then the standard deviation, I'll just do it down here because I'm out of room. Square root of n times p times 1 minus p. Okay, so we got, so let's calculate that real quick. Square root. So we get 60.75. And so they got, they had 3650 that claimed that they were satisfied. And normally the average is 3690. So let me fix this number. It's not 60, it's 19.21. Sorry about that. So they got 3650. This is what they got versus the average of 3690. So they're below. They're below by 40. So they're 40 below average. Is that cause for concern? Well, if we round this to about 20, then they're actually if I go one standard deviation, that's 3670, another standard deviation, that's 3650. So yeah, there should be concern because right now it looks like they're more than 2 standard deviations away. So they're minimum of 2 away, which means that they're outlier. That's an outlier. That means that it's that's an unusual result. Okay, so that means that they should be concerned. So the number of very satisfied students lies more than 2 standard deviations below the expected number. So the answer is C. Okay, so let's look at the free response now. Okay, so last year, the management of Piggly Wiggly grocery store has determined that only 12% of checkout transactions are paid using cash. Assume that every transaction is independent of one another. Okay, so independence, check, right? 12% looks like probability of success is the same. Daphne's working this afternoon as a cashier at this grocery store. She is interested in determining the number of customers she will need to check out until she obtains her first. Okay, so this is fibs, not bins, right? So first, so there's that. Binary, it says whether they pay cash or not, right? So binary. All right, so it's got to be geometric. Define X, the random variable interest, and state how it is distributed. So X equals the number of customers until Daphne finds the first cash paying customer. And X is a, in this case, X is a geometric random variable. Okay, so now because it's a geometric and we want the expected value, so that means, okay, so mu X is equal to 1 over P, which is 1 over 0.12, which is 8.33. So Daphne, let's see, I guess we could say interpret its meaning. So so after many random groups of customers are observed or selected, the average or expected number of customers before one pays cash is about 8.33. Okay, Daphne was told by her supervisor that she needs to check out 10 more customers before she can go on break. What is the likelihood that she has at least 2 customers that will pay cash before she goes on break? Okay, so we got P at least is greater than or equal to 2. So that means the opposite of that is X is less than 2. And so really what we just want to do is we want to do the probability that X is less than or equal to 1. So we can do 1 minus the geometric CDF of, so we got P equals 0.12 and then X is equal to 1. And we get our answer there. So if we do that, we would get, not geometric, binomial. This is a binomial because it says the likelihood that she has at least 2 customers that will pay cash. That means that we're not doing the first customer pays cash. We already have, we want 2 customers that pay cash. So this is binomial. So this is bins. Let me write that out. So binary, each one is independent. The number of trials is fixed. In this case, the number of trials is 10 customers. And then we got the success, right? So here we got 1 minus binom CDF of n equals 10. We got P equals 0.12. That's what I think that's what it was. Yeah. And then X is equal to 1. Okay. So if you were to use the formula for binomial, you could just use a formula like this: 10 choose 1 times 0.12 to the first power times 0.88 to the 9th power plus, and then you can do 10 choose, I forgot to do 10 choose 0, but let me just do that now. 10 choose 0, 0.12 to the 0 power, 0.88 to the 10th power. Okay, so that's just another way of doing it if you're doing it with calculation. All right, so if you do that, you get 0.3417. All right, so let's do part C. By the time Daphne's shift is over, she has checked out 180 total customers. What is the expected number of customers that have paid using cash? All right, what is the expected number of customers that have paid using cash? Okay, so this is binomial because we're saying, you know, the number of people that paid cash, okay, out of the 180. So mu x equals np, so 180 times 0.12, the probability. So that's 21.6 customers. All right. When Daphne goes to check out at the end of her shift, she notices the manager that she notifies the manager she had only 15 customers check out using cash during her shift. Should her manager be surprised by the number of cash paying customers that Daphne checked out? So I will point out that we're gonna use the normal approximation method for this, because you could use a binomial ideally, and then from that calculate the probabilities. You know, but we're gonna use the normal approximation method. So we're gonna use the success failure condition. So in this case, NP, so we had, so in this case we had, remember she had, by the time of Daphne's shift, she has checked out 180 total customers. So that's my N. So let me write that here. N is 180, P is 0.12. Okay, so 180 times 0.12, but we did that up here, so it's 21.6, right? And that is greater than or equal to 10. And then we have N times 1 minus P, 180 times 0.88, which is definitely greater than or equal to 10. So we're going to use a normal approximation condition, now that this satisfies that. And so we know that the mu x is NP, which is 21.6. The standard deviation is square root of NP1 minus P, square root of 180 times 0.12 times 0.88, and that's 4.36. And so we're gonna, we're gonna have a normal distribution, 21.6, and 1, 2, 3, 1, 2, 3. 4.36 is, if I subtract that from here, that should be 27.24. And so you can clearly see that if we want it to be 15 customers, or I'm sorry, what am I doing? 27.24, not 27, 17.24. If we want it to be 15 customers, then it's going to be like around here. Okay. So we want the area to the left to be less than or equal to that. All right. So so we're going to use a normal CDF. Okay. Normal CDF, lower is equal to negative 10 to the 9th power, a negative number. The upper is 15. The mean is 21.6. Standard deviation is 4.36. And we can calculate what it is for that. And actually for this type of problem, what I would suggest, instead of calculating there's a couple of things to this problem that I didn't really specify too much previously, but I'm going to expound on it here. When you got the normal distribution, we know that the cutoff is usually about 5%, right? But what does that actually mean in the normal distribution? Well, what that means is, in this case, if the mean is 21.6, right, then you can easily underestimate it or overestimate it, right? And so in this case, we would split the difference and we would say, okay, 2.5% is on each tail. Okay, so then if we are extreme in this direction and the probability is less than 2.5%, rather than the full 5%, then we would say it's too much, right? It's too extreme, and we would be surprised by that result. And in the same way, if it's greater than 21.6, such that we get 2.5%, or less than that, then we would be surprised by the result as well. And so we split the difference, 2.5% on each tail. And what that equates to is that the z has to be approximately between -2 and 2. And so the guideline here, guys, is that if the z is between -2 and 2, then you're good, right? Because remember, when we convert this to z, this is going to be 0, right? For z. So when the z value is between 0 and, or is between -2 and 2, we would say that we would not be that surprised by the result. But when we go beyond 2 standard deviations, then we would be surprised by the result, okay? And so really, when you do this type of test, you can do it, you can either compare it to 2.5%, or you can just calculate the z. And that's actually what I want to focus on. I don't want to focus on too much calculating this. What I actually want to focus on, and while you can do that here, that's not what I'm going to focus on. What I'm going to do is instead, I'm going to calculate the z. All right, so here the z is x minus mu, so 15 minus the mu divided by the standard deviation. And when you do that, you get -1.514. And so we can clearly see that this value is between -2 and 2, and therefore it's not, we would not be surprised. Okay, so not surprised by the result. Okay, so hopefully that makes sense. And another way to look at it, again, this is why it's between -2 and 2. However, when you actually calculate this, you still want to compare that to like 5% like you normally would, like the way I taught you. But when you're talking about in terms of like z, this is why the z is between -2 and 2, is because of this whole thing here, or approximately so. It's approximate. So the bottom line is, if we calculate this number right here, we would get 0.065043. And because this is greater than 0.05 or 5%, then not surprised. Okay, so in the end, we have basically two ways to do this. Calculate the probability to see if it's greater than 0.05 or less than. If it's less than or equal to, you should be surprised by the result. If it's greater than, you should not be surprised by the result. Or if you're talking about in terms of standard deviations, remember z tells you the number of standard deviations. If it's between two standard deviations within, not surprising. If it's outside of that range, surprising. So hopefully that helps, and there's a lot going on there. But hopefully you found this video useful and informative as usual. I'll see you in the next one.